I want to make just a quick video for you, for those of you that weren't in algebra today. In 9.2 number 2, we're going to use that factoring. We learned in 9.2 number 1 how to take a quadratic equation and factor it to find the two solutions, or to find what we call the zeros. And so now, how do we use that to help us graph the parabola? Okay, this is still going to be a U-shaped graph because it's still a quadratic. So if I'm going to factor this, I'm going to put a 0 here because I want to know what value I can plug in for x that's going to give me a y value or a function value of 0. So we're going to substitute 0 here. So this looks just like the problem that you had on your previous worksheet. So I'm going to factor this. Okay, and you go through the steps that you need to factor. So if you need to make an x and multiply the first and the last digits together, put your middle coefficient in there, you can walk through those steps. I know that the factors here are going to be x minus 4 and x plus 2. So if I were to set those factors equal to 0, I would get an x equals 4, or I get an x equals negative 2. So up to that point, we're doing the same thing that we did in the previous worksheet. Now the question is, how do we use that information to help us graph? Okay, if I were to draw a graph, and it'll be provided for you, you think about what these mean. Okay, so what are these points? Okay, these points are the places, the x value, where I get a y or a function value of 0. So that point would be 4, 0 on the graph, and this point would be negative 2, 0 on the graph. Because when I plug a negative 2 into there, I get 0. When I plug a positive 4 into there, I get 0. So these are actually the x-intercepts. We call those the zeros or the solutions. And so if I were to graph those, I know that the parabola is going to cross the x-axis at these two places. Now also recall that where would the axis of symmetry be? If these 2 points are mirroring each other, the axis of symmetry would be right in the middle of these two. So if you count, there's a total of 6 spaces in between those 2 points. So halfway would be 3 spaces, or right here where x equals positive 1. Okay, that's where my axis of symmetry would be. So I don't have to go through the opposite of b over 2 times a. If I did that, I would get x equals 1. Okay, and the other thing I know is that the vertex is a point that I need, and the vertex lies on the axis of symmetry. So I know the vertex, since the axis of symmetry is at 1, I know the vertex has to have an x value of 1. And if I plug it into the equation, it'll tell me what the function value is. So 1 squared is 1, minus 2 times 1, minus 8. 1 minus 2 is a negative 1, minus 8, I get a negative 9. So my vertex, and let's go by 2's in this direction. I've already gone by 1's in the x direction. So if I go by 2's, 2, 4, 6, 8, 9 would be roughly right there. And now you've got 3 points that you can use to graph that parabola. And you can make your U-shaped parabola out of that by using those 2 zeros, or those 2 factors, those 2 solutions. We get those. Those are the x-intercepts. And then I can find the vertex and have the 3 points to make the U-shaped graph. Okay, here's a second example, and just remember that when we're factoring, okay, we want to set this equal to 0, but also, what did we say about having a leading coefficient that's negative like that? Okay, we don't want that. So again, we're always looking for our greatest common factor. There's nothing that's going to divide into those numbers other than 1. But because that negative is there, I'm going to factor that negative 1 out. That's going to change the signs. This is going to become a positive x squared, a positive 4x, and a negative 12. It's going to change all of those signs. Okay, now you can go ahead and you can factor what's inside the parentheses here. Again, and to go through your factoring, you'd make an x, okay, and then you take 1 times negative 12, put your negative 12 up there. And what factors that would give you negative 4 would add up to positive 4. Okay, I'm going to say that's going to be x plus 6 and x minus 2. Okay, and if you can factor without making the x, go ahead and do it, but those would be the factors. Now, we saw this on the previous worksheet. When you take out a constant like this, you just drop that. We don't set that equal to 0. Only the things with variables do we set equal to 0. So here I would subtract 6 from both sides. Here I would add 2. So these would be my 2 solutions for that equation. And again, those solutions mean when I plug that number in for x, it's producing a 0. So it's going to be negative 6, 0 is going to be the point on the graph, and 2, 0 would be the point on the graph. So if I'm going to put those on a graph, okay, negative 6, 0 be out here, and 2, 0 would be there. Now there's a total of 8 spaces in between those 2 points, so if I go halfway between, that would be 4. 1, 2, 3, 4. This is where my axis of symmetry would be. That's at x equals negative 2. Okay, because the axis of symmetry, the vertex is going to lie on that axis of symmetry. It's going to start with negative 2, and I'd have to plug that in up here. Okay, if I put negative 2 in and square it, I get 4, and then take the negative of that, becomes negative 4. If I put a negative 2 in here, negative times a negative becomes positive. So negative 4 plus 8, that's positive 4, and then plus 12. So I'm going to get a positive 16. Okay, you're going to get some large y values, so I would probably go by 4s maybe on our graph. Okay, I'm going to go 1s in the x direction because I've already plugged those in, but I can change my interval in the y direction. So negative 2, 16 would be here, and I can draw my parabola. Notice that parabola is U-shaped, it's going down, and we should have that because our leading coefficient was negative. Okay, so we're still looking for that, and all those things that we know about a parabola still apply. Okay, this is just how we can use the factors to help us with the graph. Okay, you can work on that worksheet.